Okay, so good day. We're going to talk about the use of ASA or angle side angle and AAS, the angle side, in doing the two-column proof so that we could be able to prove that two triangles are congruent. Now, the first example here, given line segment PQ is parallel to line segment RS, and then angle PRQ is congruent to angle SQR. We're going to prove that triangle PQR is congruent to triangle SRQ. And now we are provided already with our guide here, the figure, and they are already marked according to our given. So, as we can remember, we are going to use the two-column proof. Okay, so we have the statements. So we are going to write first our statements. Okay, and then we have our reasons. Okay, so statements and then reasons. So we're going to make the two-column proof. Okay, so again, the first step that we do is to write the given. So side PQ is parallel to side RS. Okay, so our reason there is given. Alright, next. So angle PRQ is congruent to angle SQR. Okay, our reason is still given. And then, you go to the figure and check if it is already marked. So, angle PRQ, so that's angle R there, it's already marked. And then, angle SQR, it's also already marked. So, we have no problem with that. Next, identify if this is a side or this is an angle. So, this is an angle. Alright, next. So, we're going to find a clue there in which we will be given a particular reason that we can use. So in this case, we have this side, alright? So because it illustrates reflexive property, we can say that they are congruent. Okay, so number 3, let's write RQ. Okay, side RQ is congruent to side RQ. Okay, our reason there is reflexive property. Alright, so next is, okay, do we have also angles that are congruent? So by the way, this is now our side. Okay, now, we are given a clue that PQ is parallel to RS. So therefore, we can say that side RQ, our RQ becomes transversal that cuts the two parallel lines. So in this case, we have an angle or pairs of angles that will be congruent to each other. So in this case, we have angle Q and then we have angle R there. Okay, so we write that under number 4 and they are angles. So we say angle Q is congruent to angle R. And what will be our reason? So our reason is Paella theorem. Okay, so because we have parallel lines cut by a transversal, so we say that angle Q and angle R are alternate interior angles. So we are done with the ASA. Okay, so we have already an angle, we have the side, and we also have another angle. So for number 5, we are going to write the name of the triangle. So triangle PQR is congruent to triangle SRQ. And what will be our reason? So our reason is ASA congruence postulate. Alright, so this is our first example, and the first example illustrates to us the use of ASA depending on the given and how we illustrate in the figure. Okay, so next. So problem number 2. In this case, we have the given angle NER is congruent to angle NVR, and then RN, so line segment RN bisects angle ERV. So prove that triangle ENR is congruent to triangle VNR. So again, we're going to write our statements. So we're just going to do the two-column proof, two columns first, make our table. So statements, and then we have the reasons. Okay, so the first one is to write the given. So angle NER is congruent to angle NVR. So this is given. Alright. So next, number 2. The condition is that RN bisects angle ERV. So this is also given. Now, let's first go to the first given. So angle NER. So this is our angle. And then let's locate that in the figure. So this one, NER and then NVR. So it's already marked. Now, next, do we have a clue again in the triangle in which it can give us a clue that they are congruent? So we have RN as the side. So number 3, so we have this one, RN. So RN is congruent to RN. But if you want to first go to this clue that RN bisects angle ERV. So, angle, side RN bisects ERV. Okay, ERV. So, meaning to say, we will produce two angles that are congruent. Okay, so these are the two angles that are congruent. So, we say that angle R is just congruent to angle R. Okay, so the given for this is, of course, because Rn is a bisector, therefore we can say definition of angle bisector. Alright, so we have their angles also. So this is angle. And then, lastly, the particular side that we can see that are congruent to each other. So we have our Rn. So Rn is congruent to Rn. So our reason for this is reflexive property. Okay. And then we're going to mark. Now, look at the positions, okay, of the angles and then the side. So this is an angle, and the side is not included between the two angles. So therefore, it follows the AAS, congruence theorem. Okay, so number 5, triangle ENR is congruent to triangle VNR. Okay, so our reason is AAS, congruence theorem. Okay, so if ever, okay, you first write the side here, okay, you have written first the side here, and then next is the angle, that's okay. Okay, so it will still follow the AAS, not ASA. Because if you're going to refer to the triangle, okay, so it will follow the AAS, wherein the side is not included. Okay, so just be guided. Okay, be cautious about how you follow the AAS or the ASA. So this is how we use the ASA, the ASA, and then the AAS in proving the two triangles are congruent to each other.